Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
I'm here. I'm back this week. I'm so excited to be back with you guys. I was out last week, and Priya, who is amazing, was able to fill in for me. So I'm back. Here's what I need you to do first. In order for me to be able to get to know you guys a little bit better, what I want you to do is comment in the comment section what exam you're prepping for and where you are from, and whether you're rooting for the Braves or the Astros in the World Series. So where are you from? What exam are you prepping for? And are you rooting for the Braves or are you rooting for the Astros in the World Series? In this house, we're rooting for the Braves only because we don't like the Astros because we are Rangers fans. So we will be rooting for the Braves. I tried to find my Rangers t-shirt, but I couldn't. So a Texas Longhorn t-shirt had to do. So that said, I will be looking out for those comments. Let me know where you're from. Let me know what exam you're prepping for. I am so glad to be back with you guys this Wednesday. Last week, or 2 weeks ago when I was here, I had a bunch of you comment that you wanted some focused, targeted help with geometry and with slopes and algebra. So this week, I took those questions and I threw them into our content. So that's really the best way for me to develop these slides for you guys, is for you to tell me what you want help with. So if you want to see more algebra problems, or you want to see more simplifying equation problems, or you want to see more parabola problems, let me know in the comments so that I can go ahead and help you guys by developing problems that you need. So, hey, Caroline. Hey, Tanya. Awesome. From Florida, from Illinois, from Georgia, from Alabama. Roll Tide. Awesome. And we've got some 6 through 12, some GK. This is awesome. I love that you guys are letting me know because it really helps me guide our conversation. Even though the slides are already prepared, it really helps me guide where my rabbit trails go, if you know what I mean. So as Dr. A said in the intro, you can text this number below and you can get the math slides. So you can get all of these questions sent to you. So just, if you want the slides, text this number right here and say Math Stream 1, and you can get all of these slides. I apologize in advance for my voice. I did lose it. I think it's a combination of working and school and pregnancy combined. So we are due in February, which is super exciting, but I think it's all just causing this voice issue and like sinus issue. So let's go ahead and get started with question number 1. This was a question from a couple of weeks ago, so you might recognize it if you texted this number and asked for the slides. Let's go ahead and read this problem out loud. What is the axis of symmetry for a parabola whose equation is y equals 3x squared minus 12x plus 10.53? Here's what you need to know about this problem. This problem is going to be more of a 6 through 12 problem. So my elementary people, my GK people, you don't need to know this, but just understanding functions and equations and how they work is super important for everybody. So the problems that I pull, I will 90% of the time pull in information for everybody to be able to use, regardless of whether it's a problem that is going to show up on your exam or not. So let's look at some of the vocabulary that's important here. We have axis of symmetry, parabola, and then equation. An equation has an equal sign. So this is our parabola equation. How do we know this is a parabola? Well, a parabola is going to be shaped something like this, or this, or this. I mean, it could be all of those. It's a U shape facing up or down. A parabola is not facing the side. That would be an x equals y squared equation, which is not a function. So this is not going to be a parabola, nor is it going to be a function for my 6 through 12 people. So if we look at this problem, we know it's a parabola because the highest degree in my problem is squared, which means it has the potential to hit the x-axis 2 times. A cubic function, y equals x cubed, has the potential to hit the x-axis 3 times, and so on. So if we look at this problem, we know it's a parabola. What is the axis of symmetry? Well, for my elementary and especially my early childhood pre-K people, symmetry is a huge skill on the early childhood pre-K through 3 math. Symmetry means I can cut it in half. So if I'm looking at the symmetry of the letter T, does the letter T have vertical symmetry or horizontal symmetry? Well, if I cut it in half horizontally, the top is not the same as the bottom. So it would not have horizontal symmetry. However, would it have vertical symmetry? Yes, because I could fold that T in half and it would be the same on the left and the right. So we can use that same understanding here. The axis of symmetry is going to be that dotted line that cuts that shape in half, and the one side is the same as the other. So if I'm looking at the axis of symmetry for all of these parabolas, what point is it going through for all of those parabolas? We're going through the vertex. The vertex is that point that's on the bottom or the top of your parabola that is going to really make it cut in half. The vertex is where the absolute highest or the absolute lowest point is on your parabola. So if I'm looking for the axis of symmetry, really all I need is the x coordinate of my vertex. The axis of symmetry is also going to be the x coordinate of your vertex, because the axis of symmetry is a vertical imaginary line that's cutting that parabola in half. Hey, Hope, welcome back. I'm sorry I missed last week. It's good to see you again. So it's that vertical line that's cutting it in half. So if I find my vertex, or the x coordinate of my vertex, I can find my axis of symmetry. Well, I feel like I'm creating a map here. How do I find the x coordinate of my vertex? In any parabola, no matter what, the x coordinate of your vertex is negative b over 2a. So if you use that formula, negative b over 2a, you have your axis of symmetry. So let's go ahead and do that. Now, let's look at what is a, what is b, what is c. In a function, f of x and y are interchangeable. You have ax squared plus bx plus c. So this is b, this is a, and this is c. So in our original function, negative 12 is going to be b, 10.53 is going to be c, and 3 is going to be a. So x equals negative, b is negative 12. Don't forget that negative. All over 2 times a is 3. So this equals negative times negative is a what? You got it, positive. Negative times a negative is a positive 12. 2 times 3 is 6. 12 divided by 6 is 2. So x equals 2 is your axis of symmetry. Now, what if it said, what is the vertex of the parabola? Whose equation is this? Now we have our x coordinate. We would just need our y coordinate. And what can we do with that? Just plug it in. Plug that 2 in. 3 times 2 squared minus 12 times 2 plus 10.53. That would give you the y coordinate of your vertex. So let's go back to symmetry. And I'm actually going to add a little page right here, little bonus section. So for my pre-K through 3 people where symmetry is actually on your exam, what letter, can you think of a letter that would have both horizontal and vertical symmetry? So if we're talking about symmetry here, can you think of a letter of the alphabet, capital letter, that would have vertical symmetry and horizontal symmetry? I'll give you a second to comment in the comment box. That is not how you spell horizontal. Can you think of a capital letter that would have vertical and horizontal symmetry? I'm going to give you a second to think. It's a challenging question. Let's go ahead and look. Tanya, excellent job. H. Okay, that was actually going to be mine that I thought of. If we look at the letter H and I cut it in half vertically, I would have vertical symmetry, because if I cut it in half vertically, it would be the same. If I cut it in half horizontally, it would also be the same. Excellent. Hope said O. Let's go ahead and look at O. Excellent. O would also have vertical and horizontal symmetry. So good job. That addresses the symmetry part of our conversation. See, this is why it's important for me to know what exams y'all are prepping for, because this wasn't on my original list of things to talk about. But because I knew someone in here was prepping for pre-K through 3, I wanted to address it. So that's why I like for you guys to comment below. Also, don't forget to let me know what kinds of problems you want to see next week on next week's episode of Math with Amy. All right, problem number 2. A quadrilateral has coordinates P, negative 2, 3, Q, 4, 7, R, negative 3, 5, S, 6, 0. What is the difference between the slope of lines PR and RS? All right. What is the difference between the slope of lines PR and RS? What is this question actually asking us? That's the more important question. So, what is the difference? What do we think of when we think of difference? Everybody, Yes, this is a question that would be GK, Praxis Core, 6 through 12, 5 through 9, anything like that. But my elementary and my pre-K people need to know how to interpret a word problem. What is the difference? Difference means what is that gap between those two numbers? What is the change that's happening? Often we associate difference with subtraction. So what is the difference between what? The slope of lines PR and RS. So what do I have to find first? If I'm going to come up with a plan of action, I need to find the slope of PR. I need to find the slope of RS. And then I need to subtract them. I'm telling you, if you can get in the habit of at least thinking about a plan, it will really help you with these multi-step problems. So, how do I find slope? What is slope? Let's start there. Slope is rise over run. Rise over run. Now, when we think of slope, we're thinking of a coordinate graph with a line. Slope is rise over run. So I'm going up and then I'm going to the side. Y minus Y over X minus X. You gotta know that. So if you know how to find slope, you're gonna be fine figuring out this problem. I'm going to subtract my Y's and then subtract my X's. Now, some of you are saying, well, Amy, you know, the formula that I had to memorize was Y2 minus Y1 over X2 minus X1. Great. You don't need the 2's and the 1's. Here's why. You don't have to do the second one first and then the first one second. You can do the first one first and the second one second. That's fine. Just as long as the points match. So if you do this first, then you need to do this first in the X's. Does that make sense? So the 1's and the 2's don't matter. So if I'm finding slope of PR, I'm going to do slope of PR. My points are -2, 3, and -3, -5. -2, 3, and -3, -5. So I'm going to use my Y minus Y over X minus X. Which one is my Y and which one is my X? Another really important thing for you guys to know. I'm going to take this yellow banner off for a minute just so that we can see all of the things that I'm working on, but I'll pop it back up in a little bit. So, Y's. The Y's are going to be the second one. The X's are going to be the first one. Well, why is that? Because X comes before Y in the alphabet. A, B, C, D, L, M, N, O, P, Q, R, S, T, V, W, X, Y. So X is going to come before Y in your coordinate points. Y's go on top of slope because it's rise over run. So -5 minus 3. I did this one first, so I have to do that X first. -3 minus -2. A negative and a negative make a big positive, so that becomes a plus sign. -5 minus 3 is -8. -3 plus 2 is -1. Negative divided by a negative is a positive. Now I need to find the slope of RS. So I'm going to switch colors. Slope of RS. Y minus Y over X minus X. R is -3, -5. S is 6, 0. So I'm going to do -5 minus 0. Because I did this point first, I have to do that point first on the bottom. And then I have -3 minus 6. So I have -5 over -9. Negative time divided by a negative is a positive, so I have 5/9. That said, now I need to subtract them. So what is the difference, subtract, between the slope of PR, we just lost connection, between PR and RS? So I'm going to subtract 8 and 5/9. Now, if it was a negative 5/9, it would be 8 minus negative 5/9, which would then turn it into a positive. I need you to recognize that when we get to it. So if it says, what is the difference? You have to make sure you're subtracting. I'm reconnecting here, y'all. Just give me a second. Here we go. So if this was a negative, it would be 8 minus negative 5/9, but it's not a negative, it's a positive. So we're going to do 8 minus 5/9. How do I subtract now? Elementary people, I'm back with you. How do I subtract numbers that have not common denominators? I can't just subtract. So I have to get common denominators. Multiply this by 9/9. Why 9/9? Because 9/9 is 1. 8 times 1 is 8. So 72/9 is the same thing as 8. And that would give me the same denominator here. 9 times 8 is 72 minus 5/9. 72 minus 5 is 67/9. So our difference is going to be C. All right, let's keep going. Y'all are doing a great job. On a 1,500-mile road trip with 3 of her friends, Sam determines her truck consumes 14 gallons of gas for every 250 miles traveled. If the average cost of gasoline is $2.99 per gallon, how much in dollars will each person pay if they are splitting the gas bill evenly? Holy tamale, this is a ton of words. And this is a very classic GK Praxis Core question. That means it could show up on a middle school or a high school math exam as well. But again, my elementary and early childhood people, there's going to be a ton of steps in here that you need to be familiar with as well. So everybody, this one's good for you. On a 1,500-mile road trip with 3 of her friends, her truck consumes 14 gallons of gas for every 250 miles traveled. The average cost of gas is $2.99. How much will each person pay? I gotta have a plan. So I'm gonna write my plan up here. How much will each person pay if they're splitting the gas bill? Well, I need to figure out how many gallons of gas they're using. So number gallons of gas used. Then I have to figure out what is the cost of that gas. Cost of gas, like the total bill. Then I have to divide by the number of people on this trip. So how am I going to do step 1? How am I going to figure out the number of gallons of gas that are going to be used? Well, she's on a 1,500-mile road trip, and she knows that her truck consumes 14 gallons of gas for every 250 miles traveled. I'm telling you right now, there are people that will look at this problem and think that this is a D equals RT problem. Distance equals rate times time, because they see a distance, they see a time-ish, they know they're going on a road trip, and so people assume that you're using distance equals rate times time, but this is not a distance equals rate times time problem. So I encourage you to be careful when you're interpreting problems that you don't just assume because it looks like a problem that it is that kind of problem. All right, so 1,500-mile road trip. Let's just say this is 1,500 miles. And then it says for every 250 miles. So they drive 250 miles, and how much gas is that going to be? 14 gallons. Then they go another 250 miles. How much gas is that? 14 gallons. So I need to figure out how many chunks of 250 there are so that I can figure out how many gallons. So if I do 1,500 divided by 250, that will give me the number of chunks of 14 gallons we need. So I'm going to use my handy dandy calculator, Blue's Clues reference for anybody. 1,500 divided by 250, and that equals 6. That means there are 6 chunks of 250. 1, 2, 3, 4, 5, 6. What else does that mean? That means that there are 6 times where the truck is going to use 14 gallons. So if I multiply 6 times 14, I can get how many gallons of gas total I used. So 6 times 14 is 84. Now, GK and core people, we might get a calculator. Elementary people, you likely won't get a calculator. So if you had to do 14 times 6 for any reason, you would have to do that manually. Okay? So 84 gallons total. Now, I've just done a ton of work and I'm lost in where my problem is. That's why you make a plan so that you know what step comes next. Now I need to find the total cost of the gas. How do I find the total cost? Well, if this is how many gallons I'm buying and each gallon costs $2.99, I just multiply those together. $2, and I'm actually going to switch colors for this step. So $2.99 times 84, and that will give me my total cost. So $2.99 times 84 is $251.16. What does that number represent? That number represents the total cost of gas. Now, what do I need to do? Now I need to divide. What am I going to divide by? Giving you a chance to think. What am I going to divide by? I'm going to divide by 4. Why am I going to divide by 4 and not 3? Because Sam is on this trip too. So, because Sam is on this trip, it's Sam and 3 of her friends. So that's 4 people that are splitting the cost of gas. So I'm going to divide this by 4, and I get $62.79. Now, if I had divided that by 3, I would have gotten $83.72, which is D. And they know that people are going to make that mistake. So it's important you really analyze each step so that you can get that problem right. All right, let's go ahead and do a little geometry for you. So look at the statements below. This is for everybody. Everybody in this room needs to know properties of shapes. Which of the following statements describes a rhombus? We have to know what a rhombus is to be able to describe a rhombus. So if we look at this umbrella of quadrilaterals, we have quadrilaterals as this umbrella. Quadrilaterals. And then under quadrilaterals, you have parallelograms. And then under parallelograms, you have rectangles. And we have squares. But then you also have rhombuses. Quadrilaterals have 4 sides. Parallelograms, and that means that all of these shapes also have 4 sides. Parallelograms have 2 sets of parallel congruent sides. That means 2 sides are the same in parallel, 2 sides are the same in parallel. Because rectangles, rhombuses, and squares are under parallelograms, that means rectangles, rhombuses, and squares also have all of that. Rectangles have 90-degree angles in their corners on top of everything else we've just talked about. Squares have those 90-degree angles as well, but squares have 4 equal sides. The cool thing about a rhombus is it falls off of parallelogram because it does not have those 90-degree angles. It has 2 sets of congruent parallel sides, but it also has 4 equal sides. So that's the first thing that I'm going to look for when I see rhombus is 4 equal sides. So it's definitely going to be 3, which means A is out, but B has 3, 3, and 3. So now we need to look for another set of information about our rhombus. A rhombus is going to look something like this, or it's going to look like a square. A square is a rhombus. Opposite angles are supplementary, or adjacent angles are supplementary. Well, what are supplementary angles? Because the opposite angles and the adjacent angles aren't going to both be supplementary. So what is a supplementary angle? A supplementary angle is going to be angles that are 180 degrees. So supplementary angles are angles that add up to 180 degrees. So in a rhombus, what 2 angles are going to equal 180 degrees? Opposite angles or adjacent angles? Well, these angles are opposite from one another. These angles are adjacent to one another, which means they're next to each other. So opposite angles in a rhombus are going to be congruent. They're the same. Let me see if I can draw this a little bit more dramatically. Okay, we're going to pretend like those sides are the same. This angle is very obviously an obtuse angle, and this angle is very obviously an acute angle. So 2 obtuse angles are not going to equal 180 degrees because elementary and pre-K people, obtuse angles are greater than 90 degrees. Well, if 2 angles are greater than 90 degrees, there's no way they can add up and equal 180 degrees. So adjacent angles are going to be supplementary. Opposite angles are going to be congruent, not supplementary. Now, here's the thing. If my rhombus was a square, the opposite and the adjacent angles would be supplementary because 90 plus 90 is 180, but 90 plus 90 is also 180. So if it was a square, both of those would be true, but it's a rhombus, which is not guaranteed to be a square, which means 1 is out. 2 and 3 are in. 4 has exactly 1 set of congruent parallel lines. Well, we know that that's not true because a parallelogram, which is a rectangle, a rhombus, and a square as well, is going to have 2 sets of congruent parallel lines. So we're looking at 2 and 3 only. All right, let's keep going. Let's explore this problem, which is a circle with an inscribed triangle. High school people, 6 through 12, this is for you. In the figure to the right, A is the center of the circle. Which of the following must be true? So, if we've been told that this is the center of the circle, what else do we know about this circle and this triangle? We know that this is going to be a radius, and we know this is also going to be a radius. How do we know that? Because a radius goes from the center of the circle to the outside edges of the circle. So if it goes from the center to the outside, I know that those are both going to be radius. Radius are all going to be congruent. That's a radius, that's a radius, that's a radius, that's a radius. All radius are going to be congruent because they're going from the center of the circle to the outside of the circle. So if I look at this, AB has to be congruent to AC because they're both radius. So let's look at our answer choices and see what we can conclude. AB and AC are perpendicular to each other. So what that statement is trying to say is that this right here is a 90-degree angle. That is not absolutely and positively not guaranteed based on the information we've been given. In fact, I could have created a triangle that looked something like this, and we would have the same answer, and that's definitely not a 90-degree angle. Even though it looks like it could be a 90-degree angle in this picture, this is the same idea as this. So it's not. They aren't guaranteed to be 90-degree angles. A is out. B, triangle ABC is an equilateral triangle. Could BC be the length of AB and AC? Absolutely. Does it look like an equilateral triangle? With the bare eye, it kind of does look like an equilateral triangle. But we're not using our bare eye to decide this. We're using our understanding of geometry to decide this. So triangle ABC is not an equilateral triangle because there is not a tick mark here showing that that is equilateral. AB and AC are congruent. Yes, absolutely, because they are both radius or radii. I don't know which one's correct. So C is correct. D, AC and BC are congruent. What they're saying there is that this right here is congruent to this right here. And that is not true. We've not been told that. We know that the two radii are congruent, but we do not know that that bottom piece is congruent to the other two pieces of that triangle. So we cannot conclude that. So therefore, C is the only viable option in this case. All right, let's keep going. Like I said at the beginning, if you're just now joining us, if there are problems that you're seeing that you're like, man, I really didn't see her do any problems about blah, 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 type it in the comments. It helps me help you better because it allows me to know what to focus on when I'm building these problems out for you. So if you're not sure about a certain topic as you're studying, or you really wish you would have seen a problem about cubic functions or symmetry or teaching strategies or whatever, drop it in the comments so that I can include those kinds of problems in next week's slide deck. All right, let's keep going. Last week or 2 weeks ago, I did see somebody say that they really wanted some problems about slope. So let's explore some slope problems. Shown to the right are line segments AB and CD. Which of the following is true about these two line segments? Again, what I want you to remember is we're not just using our bare eye. These look like they could be perpendicular, but we're not just going to assume that. What I am going to cross off is parallel. Why am I going to cross off parallel right away? Because while I can't assume they're perpendicular, it is very obvious that they intersect. And parallel lines do not intersect. And so I can automatically cross that off. Let's look at the answer choices just so we know what we're dealing with. A, they are perpendicular lines. B, they are parallel lines. Absolutely not. C, they are intersecting lines that are not perpendicular. D, CD has a negative slope and AB has a positive slope. Well, for a problem like this, all we have to do is find their slopes and then figure out what our answer is. So I'm actually going to zoom in here for a minute on our lines so we can really work on finding the slope. Remember, slope equals rise over run, or y minus y over x minus x. That said, we need to be able to look at this and determine our slope. When they give you the graph, you can just count the squares. You don't have to do y minus y over x minus x. So let's look at line CD and determine the slope. It looks like it's intersecting at every single cross point on this graph. So between the 2 points, we are rising 1 and we are running 1. Rise 1, run 1. Rise 1, run 1. So my slope is rise over run, which is just 1. Now let's look at our pink line, line AB, and determine the slope. We have to look at where they are intersecting. So we have an intersection point there, 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 and there. So let's count our rise over our run. We're rising 2, running 1 in the negative direction. Rising 2, running 1 in the negative direction. Rising 2, running 1 in the negative direction. So rise over run in the negative direction, which equals -2. Let's go ahead and look at our answer choices. They are perpendicular. Are these lines perpendicular? Yes or no? No, they're not perpendicular. Why? Because perpendicular lines have to have negative reciprocal, I did not spell that right, reciprocal slopes. What does that even mean? A negative reciprocal slope means that if line A has a slope of A over B, line B is going to have a slope of -B over A. A reciprocal is just flipped. So a negative reciprocal is going to be a negative flip. So if I were to flip and -1, I would get -1 because 1 flipped is just 1 again. If I were to flip and negate -2, -2 over 1, if they were perpendicular, we would get +1 over 2. Are you seeing that pattern? But that's not the pattern we have. So therefore, these are not perpendicular. They are intersecting lines that are not perpendicular. Ding, 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 ding. They are definitely intersecting lines that are not perpendicular. CD has a negative slope and AB has a positive slope. Well, once we found those slopes, we found that CD has a positive slope and AB actually has a negative slope. So D is not correct either. So for a problem like this, if you know how to find slope, you're golden. You just have to be able to interpret that. Do not let words overwhelm you because this is a lot of words, but once we found our slopes, we were good. Let's go ahead and keep going. Another slope problem. Shown to the right are lines M and P. What change would need to happen to make these lines perpendicular? Again, this is one of those problems that people easily get overwhelmed with because of the amount of words. But the amount of words should not overwhelm you because you know how to find slope. So let's quickly write the slope formula on top. Rise over run. Y minus y over x minus x. We're going to zoom in on this. We're going to count our slope for each one, and then we're going to interpret what we would need to change to make the lines perpendicular. So let's look at the intersection points for M. It crosses here. It crosses here, 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 here. So what is my slope? What am I rising and what am I running? I could rise from this dot to this dot, or I could rise from this dot to this dot. It doesn't matter which direction you go, and I'm actually going to show you that right now. From here to here, we're going to go rise 1 in the negative direction. Rise 1 in the negative direction, run 3. -1, +3. -1, +3. But if I went the other way, I would rise 1 in the positive direction, run 3 in the negative direction. So either way, we have the same slope, -1 over 3. So it doesn't matter which direction you go, because the positive and the positives and the negatives will work themselves out. So -1 over 3. Let's go ahead and do our blue line. We have an intersection point here, 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 and here. So let's go ahead and explore this. We have rise 2, run 1. Rise 2, run 1, rise 2, run 1. I always check multiple points to make sure that I didn't do it incorrectly. So we're rising 2 and we're running 1. So these lines are obviously not perpendicular because we didn't go from A over B to -B over A. However, one of them is positive and one of them is negative. So we don't need to do anything with the symbols, but we do need to do something with the rise or the run to make them flip to each other. Let's look at our answer choices. The change in x's for line M would need to increase by 1. The change in y's for line P would need to increase by 1. The change in y's for line M would need to decrease by 1. The change in x's for line P would need to decrease by 1. When it says the change in x or the change in y, what are we looking at? We're looking at the difference in the two x's of line M. We're looking at this right here. So letter A, the change in x's for line M. So we're looking at the denominator for the change in x's for line M would need to increase by 1. So instead of 3, it would be 4. Is that what we would want? Would -1 over 4 make these two lines perpendicular? No, so that's not our answer. The change in y's, I'm going to change colors. The change in y's for line P, the y's are on top, would need to increase by 1. So that would go from 2 to 3 over 1. Would that be perpendicular? -1 over 3 and 3 over 1. Yes, that is perpendicular because they are flipped from each other and one is positive and one is negative. So we found our answer. Interpreting answer choices like this is always the most difficult part of an exam, a teacher certification exam. Do not let your understanding of slope get clouded by the fact that the interpretation is a little fuzzy. If you know how to find slope, you know how to do this problem. So don't let your knowledge get clouded with doubt because you see all these words and you freeze. Does that make sense? You've got this. Just pause. You knew you needed to find slope and then take it from there. All right, we have time for like one more problem. So let's go ahead and look at this one right here. On a coordinate grid, what does that mean? I'm going to stop right there because I actually was tutoring a couple of people this weekend and they didn't understand what that meant. They froze because they didn't understand what that meant. What does on a coordinate grid mean? It means that we're graphing on a coordinate grid where we have X's and Y's on a grid. That's all that means. Just interpreting these tests is the hardest part. The following functions are graphed. This is for our middle and high school people. F of x equals negative x squared plus 9x minus 20. And we have f of x equals 3. At how many points do these two functions intersect? So they have the potential to intersect twice because we know that this is a parabola. Ooh, that's too dark. We know that this is a parabola. How do we know? We talked about this at the beginning because there's a 2 right there, and that is the greatest number. So because that is a 2, we know that this is going to be a parabola. Because it's a negative, we know it's going to be an upside down parabola. And then f of x equals 3. That's also y equals 3. That's going to be a horizontal line. So it has the potential to cross 2 times. No more than that. There's no way I can get a straight horizontal line to cross a U 3 times. So that's out. Could it cross 1 time? Yeah. If it hit the vertex, it could absolutely cross 1 time. Could it cross 0 times? Absolutely. If it was way up here, it would cross no times. So it could cross 0 times. How am I going to figure that out? Well, I know that y equals 3 is going to be right here. How do I know that? Because that's where y equals 3. Over 1, up 3. Over 2, up 3. Over 3, up 3. Over 4, up 3. It's always y equals 3. So no matter what, I have y equals 3. Now, how am I going to figure out where this parabola is going to be? I need to find my vertex. Why do I need to find my vertex? Because that will give me the absolute highest point of my parabola, and it'll show me whether it's going to cross through that line, or if it's going to hit the line, or if it's just going to miss the line altogether. How do we find our vertex? Going back to that vertex formula, x equals negative b over 2a. So negative 9, 9 is your b, over 2 times a is just a negative 1. So that equals negative 9 over negative 2, which is a positive 9 over 2. Now, I know that that's my x value, which is going to be somewhere right here, but I don't know how high up it's going. So I have to plug that back in to my function to figure that out. So that's going to be negative 9 over 2 squared plus 9 times 9 over 2 minus 20. This negative happens after you square because order of operations says do exponents first. So I'm going to use my handy dandy calculator. 9 divided by 2 squared is going to be 20.25 negative. And then 9 times 9 over 2 is going to be 40.5 minus 20. Looking at that, I already know it's going to be 0, but I'm going to confirm why. 40.5 minus 20 minus 20.25 gives me 0.25. So my vertex is only going to be like right here, which means my upside down parabola isn't going to go any higher than 1/4 on my y-axis, which means those two functions don't cross. They have 0 intersection points. All right, we didn't get to 2 of the problems. We will hit those next week. If there was anything that you did not see tonight that you're like, I really need help with this, comment below in the comment box before this broadcast ends and let me know so I can add it into next week's problem set. Also, if you want the problems, you can go ahead and text the phone number on the screen and you can say Math Stream 1 to go ahead and get those problems sent to you. Thank you so much for joining me tonight. I can't wait to see you here next week. Stay tuned for a special message from Dr. A. Hey, Dr. A, are you there?
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions that I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.